Dear students, I am your course tutor Narayanasamy Rajendran. First, we will start with FHRP concepts. What will you learn in this module? Let us discuss a network scenario to understand the FHRP concepts. Assume that you are working as a network administrator in an organization. Your network is up and running perfectly without any problem. You have conquered a layer 2 redundancy without any layer 2 loops. All your devices get their addresses dynamically through DHCP server or DHCP configuration. So everything is working perfectly so far. Suddenly, one of your router, the default gateway router, in fact, has gone down, having some problem. So the default gateway router is not working. You know what happens? Due to the failure of default gateway router, none of your hosts can send any messages outside of the immediate network or to the remote network. Okay, definitely it is going to take some time to get this default gateway router operating again, or to fix this issue it will take some time. You have got a lot of angry people asking you how soon the network will be back up. So how do you solve this issue? What is the solution you will provide to fix this issue? You can solve this problem by using the FHRP protocol, first hop redundancy protocol. This module discusses about what FHRP does and all the types of FHRP that are available to you. One of this type of FHRP is Cisco proprietary FHRP called Host Standby Router Protocol, HSRP protocol. So HSRP is a type of FHRP protocol. In the second part of this module, we will discuss about HSRP, how HSRP works. The objective of this module is to explain the purpose and operation of FHRP and HSRP protocols. Also, this module explains how FHRP protocol provides default gateway services in a redundant network. Let us discuss about the FHRP, first hop redundancy protocols. This protocol provides default gateway services in a redundant network. Let us start with the question. How do you manage a single point of failure at the default gateway? For example, when a router or a router interface that serves as a default gateway fails, then the host configured with that default gateway are isolated from the outside networks. Also, the host cannot communicate with the remote networks. I hope you understand the problem. Now tell me, how do you solve this issue? So what is the solution available to solve this issue? The solution is FHRP, first hop redundancy protocol. FHRP provides solution to this issue. FHRP provides alternate default gateways in a switched network where two or more routers are connected to the same VLAN. Configuring a virtual router is one of the ways to prevent a single point of failure at the default gateway. With a virtual router, multiple routers are configured to work together. It creates an illusion of single router to the host on the LAN. When the active router fails, the redundancy protocol transitions the standby router to the new active router role, and it will forward the packets to the remote network. Default gateway limitations. The main objective of FHRP, first hop redundancy protocol, is to provide the default gateway services in a redundant network. Before discussing FHRP in detail, we will discuss about the default gateway limitation. To communicate with the remote network, the end devices must be configured with the default gateway address. If an end device are required to send a message to the remote device, then it will forward the message to the gateway router. Then the gateway router will forward it to the destination router or network. In a switched network, each client receives only one default gateway address. There is no way to use the secondary gateway, even if a secondary path exists to carry the packets off to the local segment. If you see the figure, the router 1 is responsible for routing the packets from PC1. If R1 becomes unavailable, or if the router R1 fails, the routing protocols can dynamically converge. Router R2 now route the packets from outside the network
that would have gone through R1. However, traffic from inside the network associated with R1, including the traffic from workstation, servers and printers configured with R1 as their default gateway, are still sent to R1 and the frames are dropped by the R1. The end devices that are typically configured with a single IPv4 address for a default gateway. This address does not change when the network topology changes. If the default gateway IPv4 address cannot be reached, the local devices is unable to send the packets of the local network segment, effectively disconnecting it from the other remote networks. Even if a redundant router exists that could serve as a default gateway from the segment, there is no dynamic method by which these devices can determine the address of a new default gateway. So to solve this problem, the FHRP protocol was introduced. FHRP is a mechanism that provides the alternate default gateway in a switched network where two or more routers are connected to the same VLAN. To overcome this issue, FHRP protocol should be configured along with the redundancy. Once FHRP is configured, then if the router R1 fails, then PC1 will communicate through the alternate router R2.
Router redundancy. What is router redundancy? Router redundancy is a process of creating redundant link between the default gateway routers. Why we have to create this? To avoid the single point of failure at the default gateway, and also it improves the availability of link by implementing a virtual router. So this is the use of the router redundancy. How to implement router redundancy? Router redundancy is implemented through configuring a virtual router. What is virtual router? Multiple routers are connected and configured to work together and to create an illusion to the host on the LAN that only one default gateway is available. To create the virtual router, two or more routers can act as a single virtual router by sharing an IP address and a MAC address. What we have to do after creating the virtual router? After creating the virtual router, the IPv4 address of the virtual router is configured as the default gateway address on the host and workstation. Okay, how end devices will communicate with the virtual router? When an end device required to forward the frames to the default gateway, that is now the virtual router, then the host uses the ARP, Address Resolution Protocol. We know ARP. Address Resolution Protocol is used to resolve the MAC address that is associated with the IPv4 address of the default gateway. Finally, the ARP resolution returns the MAC address of the virtual router. When frames are sent to the MAC address of a virtual router, then it can be processed by the physical router, that is by the current active router within the virtual router group. In a virtual router, we have multiple routers. It's a connection of multiple routers. Now we have to identify which physical router in the virtual router is responsible for processing the frames. We know that a single virtual router is a connection of multiple physical routers. Out of that, only one particular physical router will actively forward the frames. The other routers are in standby state. That means it will not forward anything. To identify which router is currently active or forwarding the frame, we have to use the protocol like FHRP or HSRP. The FHRP or HSRP protocol is used to identify the active physical router which is responsible for forwarding the frames on a virtual router.
As I said earlier, the redundancy protocols like FHRP or HSRP provides the mechanism for determining which router should take the active role in forwarding the traffic. It also determines when the forwarding role must be taken over by a standby router. The transmission from one forwarding router to another forwarding router is transparent to the end devices. The ability of the network to dynamically recover from the failure of a device acting as a default gateway is known as FHRP. I hope you understand what is FHRP protocol, first hop redundancy protocol. So the first hop redundancy protocol is the ability of the network to dynamically recover from the failure of a device acting as a default gateway. In this physical network topology, it shows 4 PCs, 3 routers and an internet or ISP backbone cloud. The 4 PCs and the 3 routers are connected to a LAN. The 3 routers also each have a link going up to the internet or ISP backbone. If you see here, the 3 routers combine together and forms a virtual router. In the view of the PC will assume that there is only one router available in this network. But if you see, these 3 routers form a virtual router. One of the router will act as a forwarding router. The other router will act as a virtual router. Other router will act as a standby router. We know in a virtual router, there is a forwarding router and there is a standby router. According to this topology, the router which has the IP address 192.0.2.1 will act as a forwarding router. That means it is an active router. If any PC forward the frames, it will forward it to the internet. The other routers will not forward the packets. The router which has the IP address 192.0.2.100 will act as a virtual router. It is not having any role. The router which has the IP address 192.0.2.2 will act as a standby router. So what is a standby router? When an active router fails, then the standby router will act as an active router. When the router 192.0.2.1, so this is the active router now. If it fails, then what it will do? The router 192.0.2.2 will turn as an active router. Let us discuss about this in the next slide. Let us discuss about the steps for router failover. If an active router fails, then the FHRP protocol transitions the standby router to the new active router. If you see here, the router which has the IP address 192.0.2.1 was the active router. It was acting as a forwarding router or active router. It was forwarding all the frames to the internet. Suddenly, the forwarding router fails. In this case, the FHRP protocol dynamically handles this problem. Automatically, it transitions the standby router into the forwarding router. So before 192.0.2.2 was acting as a standby router. If the forwarding router fails to perform its routing action, then the standby router will become the new forwarding router or new active router. So if any PC send the frame, then the standby router, that is the new forwarding router, will forward the frames to the internet. So here is the steps. What is the first step? The standby router stops seeing the hello message from the forwarding router. So how this forwarding router how this standby router knows that the forwarding router fails to perform or goes down? See, the standby router and forwarding router will communicate through the hello message. The forwarding router will send the hello message to the standby router. Once the standby router receives the hello messages from the forwarding router, the standby router understands that the forwarding router is working fine. If the standby router stops receiving the hello messages from the forwarding router, then it understood that the forwarding router fails, it's not working. So immediately, within a short period of time, the standby router transitioned into a new forwarding router. The FHRP is used in a production environment, largely depends on the equipment and need of the network. The below table lists all the options available for the FHRP. There are different options available in FHRP. HSRP, Host Standby Router Protocol. HSRP for IPv6. VRRP version 2. Virtual Router Redundancy Protocol version 2. And then VRRP version 3. Then GLBP, Gateway Load Balancing Protocol.
then GLBP for IPv6, then IRDP, ICMP router discovery protocol. So these are all the different options available in the FHRP protocol. We will briefly discuss about these options one by one. First, let us take HSRP. HSRP is a Cisco's proprietary FHRP that is designed to allow for transparent failover of first hop IPv4 device. HSRP provides high network availability by providing first hop routing redundancy for IPv4 host on the network configured with an IPv4 default gateway address. HSRP is used for or used in a group of routers for selecting an active device and a standby device. In a group of device interfaces, the active device is the device that is used for routing the packets. The standby device is the device that takes over when the active device fails or when preset conditions are met. The function of the HSRP standby router is to monitor the operational status of the HSRP group and to quickly assume the packet forwarding responsibility if the active router fails. So our next topic is about HSRP. In that we will discuss about HSRP in detail. Now we will move on to HSRP for IPv6. HSRP for IPv6 is also a Cisco proprietary FHRP protocol. It provides the same functionality of HSRP, but it works in the IPv6 environment. An HSRP IPv6 group has a virtual MAC address derived from the HSRP group number and a virtual IPv6 link local address derived from the HSRP virtual MAC address. The periodic router advertisement, that is RA means router advertisement. The periodic router advertisements are sent from the HSRP virtual IPv6 link local address. When the HSRP group is active, it will send this address. When the group becomes inactive, the router advertisement stops after a final router advertisement is sent. So we will discuss about HSRP in the next part of this module. Now we will move on to Virtual Router Redundancy Protocol version 2, VRRP version 2. This is a non-proprietary election protocol that dynamically assigns the responsibility for one or more virtual routers to the VRRP routers on an IPv4 LAN. This allows several routers on a multi-access link to use the same virtual IP address. We move on to VRRP router is configured to run the VRRP protocol in conjunction with one or more other routers attached to the LAN. In a VRRP configuration, one router is selected as a virtual router master with the other routers acting as a backup. In case the virtual router master fails, the backup router will take care of the routing process. Now we move on to the VRRP version 3. VRRP version 3 provides the capability to support IPv4 as well as IPv6 address. So this is a major difference. VRRP version 3 works in multi-vendor environment and is more scalable than VRRP version 2. We move to the next option, GLBP, Gateway Load Balancing Protocol. This is a Cisco proprietary FHRP that protects the data traffic from a failed router or a circuit like HSRP and VRRP, while also allowing load balancing, also called as load sharing, between a group of redundant routers. GLBP for IPv6. This is a Cisco proprietary FHRP protocol that provides the same functionality of GLBP, but it works in the IPv6 environment. GLBP for IPv6 provides automatic router backup for IPv6 host configured with a single default gateway on a LAN. Multiple first hop routers on the LAN combines to offer a single virtual first hop IPv6 router while sharing the IPv6 packet forwarding load. Now we move to the ICMP Router Discovery Protocol, IRDP. IRDP is specified in a request for commands RFC 1256. IRDP is a legacy FHRP solution. It is an old one. It's an old model. IRDP allows IPv4 hosts to locate the routers that provides IPv4 connectivity to other non-local IP networks. So these are all the different options available in FHRP.
Carefully read the question and answer the questions in the following link. Carefully read the question and answer the questions in the following link. Carefully read the question and answer the questions in the following link. In Module 9 Part 2, we will discuss about HSRP.